What if everything we thought we knew about our solar system was incomplete? For years, it was only a theory. A ghost in the data. A whispered anomaly, buried in probability, Planet 9. A phantom world too distant to see, but too massive to ignore. Now, everything has changed. Because the most powerful eye ever built by humanity, the James Webb Space Telescope, has done the unthinkable. It wasn't designed to find lost planets. Its mission was to gaze across billions of light years, into the hearts of dying galaxies and the birth cries of the universe itself. But hidden within its oceans of deep field infrared data, something stirred. At first, the signs were minuscule. Barely noticeable gravitational distortions. Microscopic irregularities in thermal readings. Ripples in the background of cosmic noise that didn't fit any known object, pattern, or explanation. Classical astronomy missed them, drowned in the noise, dismissed as data anomalies. But then, something new was unleashed. A breakthrough artificial intelligence, powered not by binary logic, but by the strange, fluid math of quantum computation. This wasn't just a machine analyzing pixels. It was a system entangled with probability itself, reading the quantum fingerprints of the universe, connecting dots we didn't even know existed. And then, from the silence, it spoke. Anomaly confirmed. Candidate object detected. Not a glitch. Not an artifact. But something very, very real. A gravitational presence, massive and slow-moving, lurking far beyond the known edge of the solar system. Roughly 5 to 10 times the mass of Earth. Its orbit elongated. Tilted. Ancient. Exactly as the long-lost models of Planet 9 predicted. But there was something strange. Its infrared signature wasn't consistent with any known planet. The heat emissions weren't steady, they pulsed. A faint, rhythmic flickering. Like a cosmic heartbeat. And then, another twist, its gravitational field wobbled slightly. Subtly? As though something was orbiting it. Or worse, as if the object itself wasn't stable. Wasn't natural. Some experts suggested a moon. Others, perhaps a ring system. But a small group, working quietly, cautiously, dared to whisper something radical. That this might not be a planet at all. That it could be a primordial black hole. A relic from the first seconds after the Big Bang. An object no larger than a city, but with the mass of worlds. Invisible to light. But felt across time. If true, we weren't just finding a planet. We were staring into the dark, ancient heart of the cosmos itself, a fossil of creation, drifting through the shadows of our own backyard. The implications are staggering. If it's a hidden planet, our entire model of solar system formation is wrong. There are worlds in the dark, giants that we never saw, shaping the Kuiper belt, steering icy bodies, sculpting the solar system in secret. But if it's a black hole, then we're dealing with a celestial ghost, a gravity well of pure density, warping space and time from the outskirts of our home system. A reminder that the universe began not with light, but with darkness. Yet the story doesn't end there. Because the Ayres analysis didn't just find the object. It tracked it. Mapped it. Predicted its path with uncanny precision. A sensor echo. An internal fault. But it wasn't. The signal was real. Verified by other instruments, other observatories. A silent, repeating pulse. A message, perhaps. or a mechanism? A growing faction of researchers, once skeptics, are beginning to ask the question that chills the spine: what if it's not natural at all? What if we've stumbled across something ancient, engineered, constructed? Could this be a probe? A beacon? The shattered remains of a long-lost civilization? A machine adrift at the edge of a forgotten stellar empire? Even the most conservative voices now admit, this object is unlike anything we've ever seen. Whether planet, black hole, or something else, its existence forces us to rethink everything. Old models are collapsing. New possibilities are blooming. And in observatories across the world, behind closed NASA meetings and encrypted data feeds, the consensus is forming: the outer solar system is not empty. It is alive. And it is watching us back. Some theorists suggest it's a captured rogue planet, a nomad from another star, pulled into our sun's gravity billions of years ago. Others go further, imagining a megastructure, designed to mask its thermal signature. Still others warn, a primordial black hole would still feed. Subtly, slowly. Distorting space, heating dust, emitting strange radiation. But regardless of the theory, one thing is clear: the cosmos just became a lot more complicated. The James Webb Telescope and its quantum AI partner have given us something more than data. They've cracked open the sky. They've shown us that the age of cosmic discovery is far from over. They've reminded us that there are places in our own solar system we still don't understand. That we've been blind. But now, we're starting to see. New missions are already in planning. Rapid probe deployment, high-orbit sensor arrays, dedicated thermal tracking satellites. Because we're racing against time. Voyager's voice is fading. The great observatories are aging. And if we don't act soon, this thing, whatever it is, may vanish once more into the shadows. But perhaps the most profound revelation is this: if quantum AI can see what we could not, what else is hidden in the starfields? How many other forces, relics, or anomalies have been lost in the static? This isn't just a discovery. It's a revolution. A new age, where human curiosity meets machine clarity. Where truth is no longer bound by our imagination alone. Where every piece of data might contain a secret. We stand now at the threshold. Beyond it, a vast, unknowable dark. A mystery older than stars. And maybe, just maybe, a key to understanding our place in the infinite. So the question isn't just, does planet